Hello guys, today we are going to see another factor which is going to influence the rate of the reaction. That is, we are going to see the effect of catalyst. Yes, on the rate of reaction. So before going to the effect part of the catalyst, first and the foremost thing we have to get to know a thing about catalyst. What do you mean by a catalyst? Remember guys, it is also a chemical substance. Okay, so what are catalysts? Catalyst is also a chemical substance. Of course, they are going to take part in a chemical reaction. So it's a chemical substance which takes part in a chemical reaction. But here we have to understand that how does it takes part in a chemical reaction? Remember, but these substances remains unaltered. ಅಂದ್ರೆ ಯಾವ ತರದ್ದು ಚೇಂಜ್ ಆಗೋದಿಲ್ಲ ಈ ಸಬ್ಸ್ಟೆನ್ಸಸ್. Though it is a chemical substances and taking part in a chemical reaction, but what is happening? They remain unaltered. First point. And the second most important point you have to remember that, and they get regenerate at the end of the reaction. These are the two important properties one has to know about a catalyst. Whenever a person is saying that it is a catalyst, you should make your mind, even though he says or he may not say, but it should get printed in your brain that, of course, whatever the catalyst they are speaking about, it is a chemical substance, of course, which will be taking part in a chemical reaction. But what it is doing, it remains unaltered. There will be no change in its composition, first thing. And the second most important thing is that after the completion of the reaction, whatever the catalyst you have chosen, that would be regenerated back. This is called as a catalyst. But now when the question arises that what is the influence of the catalyst on the rate of the reaction? Of course, we have seen in the factor, whenever you are using a catalyst, it increases the rate of the reaction. Now, when I say that catalyst increases the rate of reaction, of course, now there is a question arises. That is, so how is it? What increases the rate of reaction? Of course, in science, the most important symbol is your question mark. And the question is how, when, what, and why. These are the important things one has to know in science. So when I'm saying that catalyst is increasing the rate of the reaction, of course a question arises that how it is increasing. So in order to understand this one, we have to see what happens on the surface of the catalyst. Remember guys, whenever you're taking two reactants in the presence of catalyst, first and the foremost thing you have to remember that this catalyst will be having some surface area. Yes. So what happens? First, this catalyst allows your A and B to come and sit on it. Yes, individually. Of course, there will be no bonding between them initially. But what is happening? This catalyst forms a temporary bond with respect to that of your reactants, and also it favors to form an intermediate product. Okay. Remember, this intermediate product is highly unstable. First important thing, and they cannot be extracted. This is the second most important thing. So what your catalyst is doing, first and the foremost thing, it allows the reactants to come and sit on it, and in order to form an intermediate bond, it forms an intermediate product. This intermediate product is highly unstable, that is very high energy, and they cannot be extracted by simple means. Then what happens? whatever this intermediate product or intermediate complex, other words we can say, being unstable, what happens? Now this intermediate product or intermediate complex, whatever the bond is there, that breaks off. And then it will give rise to a product. Of course, now this product is also form a temporary bond with respect to that of your catalyst. Then what happens? Since the bond is not so strong enough, it breaks off and your product gets released. This is the important scenario which is taking place on the surface of the catalyst. That is what it is saying. So whenever you're using a catalyst, first and the foremost thing, it forms a temporary bonds between the reactants to form what? An intermediate product or an intermediate complex. Then what happens? Whatever the intermediate product has been formed, that going to decompose because they will be of higher energy, highly unstable. So now they are breaking off, and when that intermediate complex breaks off, you will be getting a final product. So this is what we can say, which is favoring the rate of the reaction. Now the question arises, okay sir, you said it is coming, it is sitting, it is forming the bond, it is breaking and it is going. Of course, when I am using without catalyst also, two molecules react and I will get the product. Then what is the use of this catalyst? Good question. In order to understand this, first and the foremost thing, I have to draw a graph for it. What does the graph says? Let us see. So let me take my y-axis as that of your potential energy over here. And this one as a reaction coordinate. Okay. Let me do a reaction in the absence of catalyst. Of course, it would be in this way. Let me assume in this way. Whatever I have got, a reaction I have got, let me consider this one as my activation. Not over, sorry. Till here. This is my activation energy. This is my activation energy. For which one? It is for an uncatalyzed reaction. What is this? Uncatalyzed reaction. True. Now, when I am using, remember this was my activation energy. So in order to reactant to give the product, we know that it has to cross this energy barrier. And of course, we know as the activation energy increases, what happens to the rate constant? It decreases. Rate constant decreases, what happens to the rate of the reaction? It also decreases. So what happens when you are using the catalyst? Please mark over here. You will be getting an alternate path. An alternate path in this way. An alternate path. In that, so now this is what your catalyzed reaction. This is what a catalyzed reaction. In the same reaction, I have used a catalyst. So now in this case, what happened? In the second reaction, when you are using the catalyst, the activation energy has been decreased. So now when the activation energy decreases, you could only see that now easily, even a small energy, even if here was your average energy molecules, they would be requiring a very small energy to cross this barrier and give you the product. So by this way, what does your catalyst is doing? It is providing an alternate path. What it is doing? Your catalyst is providing an alternate path in such a way that by decreasing the magnitude of activation energy. So when this activation energy decreases, of course, what happens? Your rate of the reaction increases. So this is the main concept when we are saying that how does your catalyst increases the rate of reaction. So first and the foremost thing, you have to remember that what is a catalyst. So when you are using a catalyst, what it is doing, it is providing an alternate path, yes, by decreasing the magnitude of your activation energy, yes. So when this activation energy decreases, what happens? Of course, the rate of the reaction increases. So this is one important factor one has to know, that how does a catalyst increases the rate of the reaction. And the most important point I would like to mention over here, remember, whatever your catalyst is there, okay, catalyst only provides an alternate path. Catalyst only provides an alternate path by decreasing the magnitude of your activation energy. This is the most important thing. And the next thing you have to remember throughout your life, that catalyst never initiates a reaction. Never initiates the reaction. Means what? If a reaction is not taking place, okay, for example, if I say that A plus B is not giving you any product. In case if somebody asks you, I'm going to use a gold catalyst, can the reaction proceed? Of course not. Why? Because catalyst never has a tendency to start the reaction. You have to remember this. Catalyst can never initiate the reaction, or in simple words, catalyst can never start the reaction. Catalyst can only provide an alternate path in order to increase the rate of the reaction. Increase the rate of reaction. That means what? If a reaction is carrying out and you have been getting a product in some case, by using the catalyst, if this, in the absence of catalyst, if we are getting in some 15 minutes this reaction, by using some catalyst you may get this in 20 minutes. So what it is doing, only catalyst can provide an alternate path to increase the rate. You can get your product at a faster rate. But do remember, your catalyst can never initiate the reaction. So keeping the second point in our mind, you have to remember that catalyst can only favor your spontaneous reactions. Catalyst can only favor your spontaneous reaction. What do you mean by a spontaneous reaction? The reaction which takes place on its own. Such reactions only a catalyst can, increases the rate of the reaction. Remember, catalyst can never used in that of your non-spontaneous reaction. Or in simple words, I could use that. What I can say is, catalyst can never favor your non-spontaneous reaction. Of course, the question lies in your second part. Spontaneous reaction means what? It needs some extra means, either your energy or either some of your power, in order to take that reaction to occur. For example, if I'm going to give you the general example, spontaneous reactions means what? If you are just switching out your motor of your pump, the water goes up. That is a spontaneous process. If I want to make the whatever the drum water is there to come to sump, what it would be? A non-spontaneous reaction. So this spontaneous reaction means what? It can take place on its own. Whereas a non-spontaneous reaction means what? It cannot take place on its own. So when a reaction cannot happen itself, how can a catalyst can affect it? That is the part you have to understand. So catalyst can only favor your spontaneous reaction, and it cannot never be favoring in that of your non-spontaneous reaction. An important thing you have to keep in your mind in this factor, that what do you mean by a catalyst? What are the two important things which is saying a chemical substance to act as a catalyst? Then how does your catalyst is increasing the rate of the reaction? That is by providing an alternate path by decreasing the magnitude of your activation energy. So then we had seen that one important thing we have to remember, that catalyst can only provide an alternate path to increase the rate of the reaction. It can never initiate the reaction. That is, it can never start the reaction. So catalyst can only be favorable for that of your spontaneous reaction, but it cannot ever be a favorable condition for that of your non-spontaneous reaction. In simple words, I could just say that catalyst can never change delta G value. The catalyst can never change, or simple words, can never alter the Gibbs energy of your reaction. So delta G ನೆಗೆಟಿವ್ ಉಂಟಪ್ಪ ಇಲ್ಲಿ ಅಲ್ವಾ. ಸ್ಪಾಂಟೇನಿಯಸ್ ರಿಯಾಕ್ಷನ್ ಅಂದ್ರೆ ಏನಾಗಿರ್ಬೇಕು, ಡೆಲ್ಟಾ ಜಿ ನೆಗೆಟಿವ್ ಇರಬೇಕು. ಅಫ್ಕೋರ್ಸ್ ಈ ನೆಗೆಟಿವ್ ನ ಅದು ಪಾಸಿಟಿವ್ ಮಾಡಕ್ಕೂ ಆಗಲ್ಲ. ಅದೇ ರೀತಿ ಡೆಲ್ಟಾ ಜಿ ಪಾಸಿಟಿವ್ ಇದ್ರೆ ಅದನ್ನ ನಾವು ನೆಗೆಟಿವ್ ಮಾಡೋಕೆ ಆಗೋದಿಲ್ಲ ಬೈ ಯೂಸಿಂಗ್ ಯೋರ್ ಕೆಟಾಲಿಸ್ಟ್. ಆ ರೀತಿಯಿಂದ ನಾವೇನಂತ ಹೇಳ್ಬೋದು ಸಿಂಪಲ್ ವರ್ಡ್ಸ್ ಅಲ್ಲಿ, ಕೆಟಾಲಿಸ್ಟ್ ಡಸ್ ನಾಟ್ ಆಲ್ಟರ್ ದಿ ಗಿಬ್ಸ್ ಎನರ್ಜಿ ಆಫ್ ರಿಯಾಕ್ಷನ್. Write it down. Catalyst can never alter the Gibbs energy of reaction. ಅಲ್ವಾ. ಯಾಕೆ ಹಿಂಗೆ ಹೇಳ್ತಿದೀವಿ ಅಂದ್ರೆ, ನಾನ್ ಸ್ಪಾಂಟೇನಿಯಸ್ ರಿಯಾಕ್ಷನ್ ಡೆಲ್ಟಾ ಜಿ ಏನಾಗಿರುತ್ತೆ, ಪಾಸಿಟಿವ್ ಆಗಿರುತ್ತೆ. ಕೆಟಾಲಿಸ್ಟ್ ಮಾಡ್ಕೊಂಡು ನಾವು ನೆಗೆಟಿವ್ ಮಾಡಕ್ಕಾಗುತ್ತಾ ಅಂದ್ರೆ, ನಾನ್ ಸ್ಪಾಂಟೇನಿಯಸ್ ನ ಸ್ಪಾಂಟೇನಿಯಸ್ ಮಾಡಕ್ಕಾಗುತ್ತಾ? ಅಫ್ ಕೋರ್ಸ್ ನಾಟ್. That is the reason we are saying as what, catalyst can never ever alter the Gibbs energy of reaction. So this was one of the most important factor. Soon after we have seen the concentration of the reactants, the temperature, and that of your catalyst. Guys, I just wanted to mention over here once again the alternate form of your Arrhenius equation. Alternate form of your Arrhenius equation. So in my earlier video I have done a small mistake in it. Okay, let us see that what was the mistake and what is the change you have to make when you are deriving this Arrhenius equation. Of course, the first and the foremost thing from the Arrhenius equation, what we know, K is equals to A into e to the power of minus EA by RT, where your R is that of your frequency factor, EA is your activation energy, R is your gas constant, T is your temperature. So of course what we did, take ln on both sides. Take ln on both sides. So what happens, this will be ln K is equals to ln of A into e to the power of minus EA by RT. So this is of the form of what, ln of A into B. Alva. So ಏನಾಗುತ್ತೆ, ln A plus ln B. But what we know, if for example log at the base e to the power of x ಅಂತ ಇದ್ರೆ ಏನಾಗ್ತಾ ಇತ್ತು, x ಅಂತ ಬರ್ಕೊಂತ ಇದ್ವಲ್ಲ, ಅದೇ ಕಾನ್ಸೆಪ್ಟ್ ನಲ್ಲಿ ಯೂಸ್ ಮಾಡ್ಕೊಳ್ಳೋಣ. ಸೊ ln k will be equals to what, ln of a ಅಲ್ವಾ, ಪ್ಲಸ್ ಆಫ್ ಇದೇನಾಗುತ್ತೆ x ಅಲ್ವಾ, ಮೈನಸ್ ಆಫ್ EA by RT. ಓಕೆ, ಇದು ನಮಗೆ ಬರುತ್ತೆ. ಸೊ ವಾಟ್ ಐ ವಿಲ್ ಬಿ ಡೂಯಿಂಗ್ ಇಸ್, ಫಸ್ಟ್ at temperature T1 ನೋಡೋಣ. At temperature T1. So what happens? Of course, when the temperature changes, your rate constant also changes. So I can write it as what? Ln K1 is equals to ln A minus EA divided by RT1. Similarly, at temperature T2. So what I can do? Ln K2 is equals to ln A minus EA divided by RT2. Okay. So let me consider this one as A and this one as B. Of course, we did it as B minus A. There was a mistake in this case. So what did I do? ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ, ln K2 minus ln K1 alva. Yes. So then what happens? This and this gets cancels off. But do remember, I am doing B minus A. What should I have written? Minus of EA divided by RT2. Yes, minus of minus alva. Can I the B minus A? So here is a minus is there. So minus this minus of minus. So what will be getting? EA by RT1. Of course, minus into minus will be plus. So ln of this will be what? K2 by K1 is equals to, if I take EA by R out, I would be getting as what? Minus into minus plus. So I will be writing first 1 by T1 minus then 1 by T2. So this was a mistake we have done in our previous video. So what did I do means, I just to put this sign, there was a mistake. Please check it out. You will be getting as ln of K2 by K1 is equals to EA by R of 1 by T1 minus 1 by T2. what was the misstatement we have got over there as what? 1 by T2 minus 1 by T1. Please make it a correction over here. This is your correct form. In case if I am putting my log, of course you'll be getting as log K2 by K1 is equals to what? EA divided by 2.303 into R of 1 by T1 minus 1 by T2. Okay. So this way you have to remember. Notice that first comes K2 by K1. But when you are seeing your temperature, you will be having first 1 by T1 minus 1 by T2. So this is your correct form, correct in your notes. And this is one of the most important formula you have to remember, because depending upon this formula, of course, one problem is going to arise in your board exam. So this is an alternate form of your Arrhenius equation. Soon after you have deriving any formula, it would be, please define whatever the notations you have used, that is K2 is a rate constant at temperature of T2, K1 is a rate constant at temperature of T1, A is your activation energy, R is your gas constant, of course T1 and T2 are your temperatures in Kelvin. Very much important. Whenever if they are in the problem, if they are giving in the degree Celsius, do remember that first and the foremost thing you have to convert that temperature to your respective Kelvin. Of course, this is your activation energy. Of course, we know the activation energy. Energy means joules. Okay, but activation energy generated would be given in joules per mole in this case. Of course, you can write the joules also, but it is better that you follow the notation of joules per mole. Then that of your K2 and K1, since they are the constants, depending upon the order, you have to mention the what would be its unit. Okay, so remember, whenever you are doing any derivation, first and the foremost thing, you have to explain the notations you have used, and you have to see that what are the respective SI units. Is that clear? So this is, please correct it off, don't leave it. Of course, in our previous video, I have just made a mistake of 1 by T2 minus 1 by T1, but it is what? 1 by T1 minus 1 by T2. Okay. So in our next video, we will be going to see another factor depending upon an orientation and that of your collision.